So yesterday we discussed about the momentum which is a product of mass and velocity. The product of mass and velocity, what we call that as momentum. And the impulse, so momentum is a product of mass and velocity. What about impulse? Impulse is a change in momentum, so it is a final momentum minus the initial momentum. Or impulse can also be a product of force and time. Then we did the conservation of the momentum, that the total momentum before collision should be equals to total momentum after the collision. So if we have an object of mass m1 moving with velocity u1 collide with another mass m2 moving with velocity u2. So what is the total momentum before m1 u1 plus m2 u2? And once they collide, the mass won't change, the speeds will change, the velocities. So if m1 and m2 the masses, so the final momentum will be m1 v1 plus m2 v2. So according to conservation of the momentum, that m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Now, today's topic is types of the collision. When objects collide, they may have elastic or inelastic collision. What is the difference between an elastic or inelastic collision? Whenever there's an elastic collision, what will happen? The momentum will be conserved. And the kinetic energy will also be conserved. Means when we say, or when we use the term conserve, it means the momentum before should be equals to momentum after, and the kinetic energy before will be equals to kinetic energy after. But what happened in inelastic collision? In inelastic collision, the momentum is conserved. But what happened to the kinetic energy? The kinetic energy is not conserved. Means the kinetic energy before is not equals to kinetic energy after. So the main difference between the elastic and inelastic collision is the conservation of the kinetic energy specifically. So what might happen in inelastic collisions are mainly the collision which we observe, the practical collision. These are all inelastic collision, because what might happen when objects collide, some of the energy might be lost or transferred. Some of the kinetic energy might be transferred in the form of heat, in the form of sound, or may turn into elastic strain energy. So when the energy transform into other forms, what kind of collision we call? We call that as inelastic collision. But if the energy does not transform to other form, what we call them as elastic collision. So momentum is conserved in both collisions. The only difference when we compare the energy, the kinetic energy before and after, the kinetic energy before and after is not conserved in inelastic collision, but it is conserved in elastic collisions. So if I say the kinetic energy before was 300 joules, and the kinetic energy after the collision is also 300 joules. So what kind of collision is this? Elastic or inelastic? The kinetic energy before is equals to kinetic energy after. So what we can say this type of collision? So we can say this is an elastic collision. But if I say the kinetic energy before and after, the kinetic energy before is 300, but after is 280. What kind of collision is this? Inelastic collision. So the kinetic energy before and after is not same. And why it is not same? Some of the energy is transformed in other form, such as sound, heat, elastic strain. That's why it is inelastic collision. Can I write 300 joule was before and 330 joules is after? Can I write the statement like this? Yes or no? 300 joules was there at the beginning and 330 joules is after. So I cannot write the statement like this because it should always follow a law of conservation of energy, that the total energy before should be equals to total energy after. So the elastic collisions are the one in which the kinetic energy is conserved, and inelastic is the one in which the kinetic energy is not conserved. Is it clear, the concept of elastic and inelastic collisions?
Yes, sir.
Now, collision in 2 dimension. As I mentioned here, this is for students taking Cambridge. For them only, it's a topic. For student taking Edexcel, this is a topic for them in A2. You will study the same topic, but not in AS. You will study in A2. So collision in 2 dimension, what does it mean, the collision in 2 dimension? Example, we have two objects. M1 and M2. Okay. And M1 hit M2 and it changes the direction. So what we call this type of a collision, we call that as a collision in 2 dimension. Why we call collision in 2 dimension? Because the direction has changed, the dimension has changed here. So because we have two component, X and Y component, but initially it was having only X component. Example, this is M1 and this is M2. Say this was moving with velocity U1. This was, example, initially at rest. Example. And after the collision, the velocity is V1 here and the velocity is V2. This is M2 and this one is M1. And they're making an angle with an x-axis. If you took an x-axis here, so one of the angle is theta and the other angle is, example, phi. Okay. So one of the angle is theta and the other angle is phi. Now, when the objects are colliding in 2 dimension, like the collision is in 2 dimension, how we can write? We separate the motion. We separate the x direction motion, the horizontal motion, and we separate the y direction motion. So if I want the x direction motion, the conservation of momentum, the x direction, what is the conservation of momentum in x direction? So this mass is m1 and this velocity is u1. So I can say m1 u1 plus the second object was stationary, it was not moving. So if the second object is not moving, what I can say? I can say that its momentum is 0. So I can write 0. Now, what is the momentum after the collision in x direction? So because as you can see here, they have the both components x and y. So, but I need the component in x direction. So what will be this component for M1? If I need the component for M1 in x direction, so what is this component? It will be M1 V1 cosine phi. Is it clear? Or this is M1 V1 cosine phi. Why? Because it is with an angle. Same thing, what will the component for the M2? So this will be equals to M2 V2 cosine theta. So these are the components in x direction. So when I write the equation for x direction, I will say M1 V1 cosine theta plus M1 V1 cosine phi plus M2 V2 cosine theta. Is it clear? This equation which I wrote for x direction. Anyone having a doubt or a question till this point? Any doubt or a question? Momentum in x direction. Yeah, I will repeat. Look, whenever objects are colliding and if they change the direction, in x and y, so we use a conservation of the momentum in both direction. What is the conservation of the momentum in both direction? Like the sum of the momentum before must be equals to sum of the momentum after. But because the object has changes the direction, because it is changing a direction, so it will have two components. So what is the component in x direction? The first one is m1 and u1. So the momentum for the first object is m1 u1 plus what is the momentum of the second object, because it was not moving. So the momentum of the second object is 0. Now, because we are talking about momentum, so that's why we need the product of mass and velocity both. So what will be the component here? In x direction, because it will have two components, one of the component in x, another one y. Same thing for the other one is in x, another one is in y. Now, if you want the component here for this m2, so because this is with an angle, so how we can write? We can write m2 because we need the momentum. That's why momentum is a product of mass and velocity. But we don't take a velocity v2. We just take a component of the velocity. So it will be v2 cosine theta. So always the component which is with an angle is written with cosine. Same way, we need this component. The momentum is a product of mass and velocity. So m1 v1 and the angle is phi. So we can say m1 v1 cosine phi. That's why if we only take the motion in x direction, if we only take the motion in x direction, we exclude the y direction. So we exclude the y direction. So you will find that in x direction, it is m1 v1 cosine theta, cosine phi plus m2 v2 cosine theta. That's why when we write here, we'll write m1 v1 cosine phi plus m2 v2 cosine theta. In x direction, we take cosine, and the y direction we'll take as sine because that's a component. Now, this is a equation for the conservation of the momentum in x direction. What about the conservation of momentum in y direction? Like this is a y component here and this is a y component. So what will be this component? So it will be m2 v2 sine theta, and this will be m1 v1 sine phi. Now, if you want to write an equation for conservation in y direction, first, what the momentum before should be equals to momentum after. This object is not moving in a y direction, so its momentum in the y direction is 0. Same thing, m2 is not moving at all, so it does not have any component in the y direction, so both are 0. But what about the final? One is having a vertical component upward, another one vertical component downward. So we can say any one of them we can say as positive, the other one will be negative. So if I take upward direction as positive, the downward direction will be negative. So I will write m2 v2 sine theta minus m1 v1 sine phi. So this is a conservation of the momentum equation in a y direction. So this was in x direction and the other one is in a y direction. So whenever objects changes the direction, we resolve the momentum into the component, and one we took in x direction, another one we took in y direction. Is it clear? Any doubt in this? So we will always resolve the motion into the component. And when there's a collision, if there's an elastic collision between the two objects of same mass in 2 dimensions, the angle between the final momentums will be 90. So whenever there's an elastic collision between the two objects which are having the same mass, so the angle will be 90. Like example, if we say we have two objects which are having a same mass and one is stationary. One of them is not moving, one of them is initially at rest. This is 2 kilogram. This is also 2 kilogram. And one is stationary, one is moving. If the collision is elastic, what will happen after the collision? Elastic collision means the kinetic energy is conserved. So after the collision, like example, the one object is moving with both changes the direction, like they have the two components, X and the Y. So after the collision, what will be the angle between them? If the collision is elastic, this angle will be 90 degrees. So if this angle is 90 between the two objects after the collision, if when one of the object is stationary and one of the object moves, and they have the same masses as well. The condition is that if the two objects have the same mass and they collide, so after the collision, they will have the angle between them will be 90. How we can prove that the angle will be 90 between them? Look, we know in elastic collision, the kinetic energy before, the total kinetic energy before is equals to kinetic energy after. That is what we say. Example, we have two objects of same mass. They collide. The mass is m1 here. It is moving with velocity u1. The mass is m2, but it was not moving. After the collision, example, m2 moves in this direction and m1 moves in this direction. The final velocity of mass 1 is v1 and the final velocity after the collision is v2. When we compare the kinetic energy, we don't bother about these angles. Why we don't bother about the angle? Because the kinetic energy or energy is a scalar quantity. So when you have a scalar quantity does not depend on the direction. So when I say the kinetic energy before should be equals to kinetic energy after, kinetic energy is half mv squared. So when I write this statement, I will write half m1 u1 square plus 0. Why 0? Because this object was not moving, equals to kinetic energy after. So it will be half m1 v1 square. Why I did not take, even though it is making angle, like example theta here, and it is making angle phi, but when I'm writing an equation for kinetic energy, I don't bother about the angle because the kinetic energy or energy is a scalar quantity. So in scalar quantity, if the direction change, we don't consider that. We just take a magnitude. So what will be the magnitude of the kinetic energy? It will be half m1 v1 square plus what is the magnitude of the kinetic energy of the second object? It will be half m2 v2 square. But in the question, I said that if two objects have the same mass, so m1 and m2, example, they are m, same mass. So if I simplify this equation, I will simplify here this equation. So m1 and m2 are the same masses. So I can say half m u1 square is equals to half m v1 square plus half m v2 square. So as you can see here, I just substitute the m1, m2 as m. If I take m and half common, so it will be half m u1 square is equals to half m v1 square plus v2 square. So half m I took common from the right hand side. Now half m is common, so I can cancel out. So this half m can cancel out with half m. So u1 square is equals to v1 square plus v2 square. Can you relate this relation, like the equation, with any mathematical equation? If you remember the Pythagoras theorem, what is the Pythagoras theorem? It says the hypotenuse square is equals to the base square plus the perpendicular square. That's a Pythagoras theorem. So that's how the equation for the Pythagoras theorem written. And we get u1 square is equals to v1 square plus v2 square. So means this equation resemble with the Pythagoras equation. So it means that after the collision, what will happen? It will make a right angle triangle. And if it make a right angle triangle, like V1 and V2, one will be the base, one will be the perpendicular. So what should be the angle between the sides of a right angle triangle, like the base and the perpendicular? It will be 90. So whenever there's an elastic collision between the two identical masses, and if one of them is stationary, that's a condition, like two conditions, identical masses, and one of the mass is stationary. If the collision is elastic, the angle between the final velocities will always be 90 degrees. If it is not 90, it means the collision is inelastic. Is it clear, this concept of the elastic collision and how we can relate in two dimension? Anyone having a doubt or a question in this? Why won't one stop and other only move? One stop and other only move. Imad, it's a good question, but it depends on the mass. Like if one of the object is heavy and the other one is lighter, then it can happen. But if two identical objects are there, so in that case, it cannot happen that one stop and the other move. If the two objects have a large difference in the mass, then one will stop and the other will move. Or if there's a friction in the no, in a billiard balls or a pool, what actually happened, the friction is also there, which play a role, the friction of the surface. So if you don't have a friction of the surface, it can never happen that one object will move and the other stop completely. If there is no friction, it cannot happen. You need a system to have a friction so that one will move and the other will stop completely. So perfect elastic collision, the object will changes the direction. Is it clear? The momentum collision in two dimensions? Example, this is a word example. A particle moves towards a stationary particle of equal mass with a velocity of 2 meters per second. So we have two particles, identical mass. So this object is moving at a velocity of 2 meters per second. After the collision, one particle moves off with a velocity of 1 meter per second at an angle of 60, original velocity. So this is the before, but after the collision, what happened? One of the particle moves at an angle of 60 degrees. From the original direction. So this angle is given 60. The second particle moves off with a velocity of 1.3. So this particle, can this happen that M1, M2 moves in opposite direction as shown? Like if M1 and M2 moves in opposite direction, it can only, yes, it can happen. But in that case, it happened when the explosion occurred. Like if two objects are there and it explode, M1 and M2 will move in opposite direction. If we want a object to move in opposite direction, like example, then say one of the object is stationary and the other object is moving, and the thing is we want this object to bounce off. So the momentum of this object should be 3 times the momentum of this one so that it can bounce off. So it should have a very high momentum to bounce off. In that case, it is a possibility. So one of the particle move off with a velocity of 1 meter per second. So this is 1 meters per second at an angle of 60. The second particle moves off with a velocity of 1.73 meter per second. Calculate the angle of the second particle. So we need this angle. We know the velocities is 1.73 meters per second. And this angle is unknown. We can say theta. Okay. Now, to solve such question, what you can do, you can take the momentum in x direction or y direction. Okay. So, because what we can do here, simplify, because in y direction, usually, or in perpendicular direction, usually we don't have the initial one. So, what we can do, we can use a conservation of momentum in y direction. So, if we take a conservation of the momentum in y direction before the collision, there is no momentum. So, that is 0. Clear? After the collision, if one is going up, the other is going down. So what is the momentum of this object? The both have the same identical mass as they mentioned in the beginning of the question. So the momentum is a product of mass and velocity. So it will be, why not in x direction? I can take x direction as well, but in x direction, I will have a lot of numbers to solve. Like I can also take x direction, I'll get the answer. It won't make difference. But in x direction, what if I took an x direction and I try to solve a question? It will work, but I will have more numbers to solve. Like when I took x direction, so what is the momentum of this one? It will be 2m before. This is 0 because it was stationary. What is the momentum after? So the x direction momentum, so this will be m into 1 or 1m you can also say, because mass into velocity 1m, and it will be cosine 60 plus what is the momentum of this one? It will be 1.73 m cosine theta, because this angle we want to find. So I can solve this equation as well. From this equation, I will find the value for theta. I'll get the same answer as if I use a y direction. In the question, they use a y, but you can use x, you will get the answer. If you use a y, the object is not moving in a y direction, so initial momentum is 0. For the y direction here, one is going up. So means what about this momentum? It will be 1m sine 60. And the other is going down, so that's why we will take as negative. So minus, it will be 1.73 m sine theta. And you can simplify for theta here. You will get the value for theta. Is it clear? So we just have to solve for theta. Even we can take x or we can take y. But why in this example they took x? Well, they took y rather than x because the number of the values in x are more as compared to that in y. Is it a clear discussion? Why won't we directly know it should be 30? Yes, we can directly know if it is, if in the question they mention elastic collision. For example, if one of the statements was there that the collision is elastic, then I will directly use, like example, one of the angle is 60. So what will be the other angle? Definitely should be 30. And in the question, they took, as one of the student is mentioning, they took the vertical one. Look, they took the vertical one both as positive because they consider both are moving in the same vertical direction. But when they worked out, they got a negative answer. So if they got a negative answer, like negative 30, it means it is not in the same direction. They are not moving in the same direction. They are moving in opposite direction, or angle is opposite for a vertical collision. So you can, if you take from the beginning, you took negative and you got a positive answer, means your direction is correct. But if you took positive and you're getting a negative answer, it means the direction is actually opposite what you took. So they consider that the both objects move in the same vertical direction. But in practical, it won't happen because the momentum should be conserved. So if one is going vertically up, the other should go vertically down. Is it clear? This example, anyone having a doubt or a question? So if you take negative here, then your final answer will be plus 30. It means you took a right direction. If you take a positive here, you get a negative 30, means you took the direction upward, but actually the direction is opposite. This example 6.6 is from the book. So two people, A and B, of masses 70 kilogram and 50 kilogram respectively, skis with a velocity of 6 meters per second and 8 meters per second along the direction as shown in the figure. They collide and hug each other after the collision. What is their velocity after the collision? So here, as I mentioned, they hug each other. It means they will have the same velocity. And then the second part is, what is the fraction loss in the kinetic energy? So we'll use the conservation of the momentum. Like the total momentum before should be equals to total momentum after. So if I draw a vector diagram, because if vectors are given, so the sum of the momentum before must be equals to sum of the momentum after. So the momentum before, I can draw any one of them first because the vectors are given. So example, this is 17 to 6 momentum, like 6 meters per second momentum. And this one is the momentum of 50 kilogram moving at 8 meters per second. So this is the momentum before. So 6 meters per second, speed 8 meters per second. The mass was 50 kg for this one, and the mass is 70 kg for this one. What will the momentum after? The momentum after, from tail of the first to the head of the last, when we join, we get this will be the vector diagram, because momentum before, the sum of the momentum before is equals to sum of momentum after. So what will the momentum after collision? So momentum after collision will be equals to m1 plus m2 into velocity v. So means when they collide with each other, which direction likely they will move? This is the direction likely they will move. Is it clear till this point? So what is the momentum of this one? 17 to 6. So 17 to 6, 7 multiplied by 6, 42. So this will be, I will draw 420 momentum. What about the second momentum of the second object? 50 into 8, 400. So this will be 400. And according to conservation, the momentum before equals to momentum after. So this will be the momentum after. When we add the two momentum, we'll get the final momentum. So this will be the final momentum of the two. Now, how we can work out, as you can see, what it is making a right angle triangle. So if it is making a right angle triangle, what I can use a Pythagoras. So the final momentum will be equals to under root 420 square plus 400 square. So what's the answer? The final answer for this?
580.
580. So we got the final momentum is 580. but we need their velocities after the collision. So if we need the velocity after the collision, what we can do? We can we work out the conservation of the momentum, and we know the momentum is a product of mass and velocity. So the final momentum will be equals to the product of mass and velocity. So final momentum we already worked out, which is 580. And the total mass, because they hug each other, so the total mass will be the sum. So it will be 70 plus 50, which is 120. So 580 divided by 120. What's the final velocity here? What's the final velocity?
4.83.
So the final velocity will be 4.83. Is it clear, this example? Meters per second. Any doubt in this? Any question or doubt in this?
No, sir.
Okay. And remember, elastic collision, we can predict the collision is elastic if the final moment, finally they are 90 degree, not initially. This is initial 90. Initially, if they are 90, we cannot predict if it's elastic or inelastic. But after the collision, and it's not like two objects should have the same mass. The condition is that the mass of the two objects should be same and one of them should be stationary. And if they collide, if the angle is 90 after, it means the collision is elastic. Then to work out the fraction loss in kinetic energy, we use the formula half mv square. So half 70 into 6 square plus half 50 into 8 square. That is before. And what about after half? The mass is 120 and the speed is 4.83 square. So we'll work out before and after and we subtract to know how much energy being lost. It will be about 1400 energy will be lost. Is it clear now?
Yes.